Good morning. Today I'm going to do some examples for you for practice 13.1 quadratic functions. There aren't very many problems on the worksheet because there's several things that it's asking you to do for each of those problems. So let's talk a little bit about these quadratic functions. First of all, we know that our function is the standard form of our function is y equals or f of x equals or 0 equals ax squared plus bx plus c. So our a is our coefficient of our squared term, our x squared. Our b is our coefficient of our linear term, our x term, and our c is our constant term with no variable. Now that's important because when we go to do this number one that they ask us to do, determining the vertex of the quadratic function, then we have to substitute those values into our vertex formula, which is x equals the opposite of b over 2 times a. And then once we get our x, we'll substitute it back into the original equation, and that'll give us our y, and that'll show us our vertex point, either our maximum or our minimum point of our graph. So in our example they give us, our a is -2, our b is 4, and our c is -3. So when we substitute into our minus b over 2 times a, we get -4 over 2 times -2, which is also -4. So our x is 1. And then if we substitute back into our original equation, we have -2 times our 1 squared plus 4 times our 1 subtract 3. And that's going to give me, what? -2 plus 4 is 2, take away 3, -1. So at 1 comma -1, so right about there, that's our vertex. So it's either going to be the maximum point or the minimum point, which is number 2 that we're supposed to do, describe whether the vertex is minimum or maximum. Ours is a maximum, and we know that because our a right here is -2. And when our a is negative, then our vertex is always the maximum point because our parabola, our graph of our quadratic function, always opens downward. In other words, it has a general shape like that. So this is open. This is what we call open. So that's open downward. So I just answered part 2. Our point here is going to be a maximum point, and that means that our graph opens down. All right, then number 4 asked me to create a table of values. Normally we get 3 or more values, probably 3 to 5 values. A lot of times if you get more than 3, the numbers get too big that they won't fit on our piece of graph paper. So let's try 3. Let's do -1 for x, 0 for x, and 1 for x. So we're going to substitute back in just like we did a minute ago with our +1, which we already know that our +1 got us a -1, so we can fill that in. And in this case, because all my numbers are to the left of my vertex, I probably ought to choose 2 and see what happens at +2 also. So at -1 squared is 1 times -2 is -2, and -1 times 4 is -4, and my subtract 3 is just subtract 3. So -2 subtract 4 subtract 3 is -8, no, -9, my bad, -9. So -1 comma -9, so about right there is on my graph. If I substitute 0 in, I get -3, because all those x's become a 0, so I get -3. And then +2, I'm thinking is going to give me probably -3 as well. Let's see. +2 squared is 4 times -2 is -8. Positive 2 times 4 is positive 8, so those cancel. and minus 3 is going to give me negative 3. So 2 comma negative 3. All right. And then let's add one more. 3 should give me the same answer as negative 1. Let's make sure so we can get our 5th point in there. 3 squared is 9 times negative 2 is negative 18. 3 times 4 is positive 12, and then our minus 3. So negative 18 plus 12 is negative 6. Take away 3 is negative 9, and that's what we thought would happen. So there's our 5th point, and then we try to make that look like a curve, and so it looks like that. And we've satisfied all 5 of our instructions. We found the vertex, we determined whether it was a max or a min, we said whether it opened up or down, we created a table of values, and we sketched a graph. Great job.